Why waste time in commute and spend lot of money for iit-jee coaching? Parents, do you want your kids to achieve top scores in iit-jee? India's leading online NEET coaching 100% success iit-jee. At TeenEinstein, we focus on iit-jee coaching from Class 6 to Class 12. We think you'll like it. Our teachers are mostly PhDs in physics, maths, chemistry, botany, and zoology, with lots of years of teaching experience for Class 6 to Class 12. Thousands of videos, quiz, MCQs. We provide a daily worksheet of 30 questions on each topic: math, physics, chemistry, and biology, for rigorous practice, concept understanding, evaluation, quiz, and thousands of videos. Limited offer 40,000 rupees per year. Book your class. TeenEinstein.com.
Hello students, welcome to the PYQ discussions on JEE Advanced Papers. Here I have got a problem from JEE Advanced Paper 1 2023. The problem says an optical arrangement consists of two concave mirrors M1 and M2 and a convex lens L with a common principal axis as shown in the figure. So these are M1 and M2, these are two concave mirror and L is the convex lens. The focal length of the lens L is 10 centimeter. So this has got focal length 10 centimeter. The radii of curvature of M1 and M2 are 20 centimeter and 24 centimeter respectively. That means this has got focal length. If we require focal length for this is 12 centimeter and focal length for the mirror 1 is 10 centimeter. The distance between L and M2 is 20 centimeter. So that is given here. You can see this is the lens and this is mirror M2 and the distance between them is 20 centimeter. A point source S is placed at the midpoint of L and M2. So this is the point source which is kept exactly at the midpoint. That means this is 10 centimeter. This is also 10 centimeter. Okay, when the distance between L and M1, that means you need to find out the distance between these two, M1, mirror M1 and lens. When the distance between L and M1 is n by 7 centimeter, one of the images coincides with S. The value of n is dash. So you look here, you have to find out the distance, that particular distance between M1 and L, for which at least one of the images will be coinciding with the source itself. That means the final image will be forming at the source. So this is the question. See here, all three having the same principal axis and all these three is making a single optical device. And for this question, this optical device has to be used such that the final image is formed at the source itself. This is simply the question is. So you have to find out what is that particular distance between the convex lens and the mirror 1 for which the image will be coinciding, at least one image will be coinciding with this source. See, first of all, let me tell you, if I consider that this source is in between this lens and this mirror M2. If I take into consideration that the first image is formed by the lens, then that will act as object for M1 and then the ray will be reflected back and refracted through lens again and then final image will be formed by the M2 after reflection from there. If we want to think in that way, we will be able to see here that we are not going to get the final image formed at this S in any situation. So see, I have explained with this ray diagram. You can see that if I just take this source, okay, so this is my 10 centimeter, okay, so this is, that means this source is at the focus. of this lens. So rays after refraction will be parallel, these rays, and these parallel rays will be reflected by M1. If that is happening, the reflected rays from this mirror 1 will pass through the focus of this. So this is also again 10 centimeter. After passing through this focus, these rays will be again refracted by this lens. These rays, see, if this is again, see, as I have taken, these rays are reflected by this, and after refraction through the lens, these rays are going to be again, like they are not going to meet again at this particular position or at the source. This is my conclusion here. Okay, see, these rays after reflection, see, if these are parallel rays from, say, one situation I am showing you here, that if this is also 10 centimeter, okay, 10 centimeter, okay, then these rays after refraction will be parallel. So parallel rays are reflected from this M2 mirror. After reflection, they will pass through the focus of this. So focus is not 10 centimeter, 12 centimeter for this M2. So they will actually pass through this, okay, like this. So the final image is not going to form at this. So let us not consider this way. Let us try to find out the image formed by M2 first. Okay, so let us consider that thing, that so for M2 mirror. Okay, for M2 we know this object distance to be minus 10 centimeter, and focal length for a concave mirror that will be minus 12 centimeter. So we have to find out the V. Okay, I need this space, so let me away from here. So I know this 10 centimeter, I know focal length minus 12 centimeter. So I have to find out what is V. For mirror we know 1 by V plus 1 by U is equal to 1 by F. Okay, then if I take this U to the other side, I'll get minus of this. So if I just take the values F and U with proper sign, then I get minus 1 by 12 plus 1 by 10. And if I do the LCM, you will get, see here it is 60, and you will get minus 5 plus 6. So you will get 6, see, V to be 60 centimeter. That means if I take the rays like this, then the image formed by this mirror will be, see, this is positive, V is positive, that means there will be virtual image produced by this M2 mirror. Okay, so this virtual image, so this is 1. Now this image will act as an object for this lens. So see, the object distance will be, now this is 60 centimeter. If I consider the image formation by lens, now see, the situation is here. Okay, so the image is formed by M2 is at 60 centimeter, and that is the virtual image. Now this image will act as an object for the lens. Okay, now see, these are the rays which are getting refracted, and they will form the final image. I don't know what is this distance. Let us find out what is this distance is. Okay, so for the lens we get U is equal to 80 centimeter. See, if I take the rays, the direction of rays in this way, but I am just measuring the distance in this way. So this U I can take, see, I am just measuring in this way, so I can take this as positive. But focal length I have measured from here, right? So focal length 10 centimeter, I can take this as negative, or other way also you can take this as minus, and this focal length to be positive, whatever way you can take. This is 10 centimeter. Okay, alright, now you take this, see, 1 by V minus 1 by U is equal to 1 by F, right? So 1 by V will be 1 by F plus 1 by U. So 1 by F is equal to 10, so 1 over 10, and this will be minus 1 over 80, right? So what you get? This is 80, and this is 8 minus 1, so it is 7 by 80. So which gives you the value of V, that is the image distance, or the distance of the image formed by the lens. Okay, that means this I2 is the second image which is formed by lens. Now what will be the distance between this mirror M1 and the lens by which you will get the final image formed at the source? That depends on the position of the image formed by this L. I think you might be a little bit confused. Let me explain you once again. See, the distance between the mirror M1 and the lens L for which the final image will be formed at the source itself will depend on the position of the image I2 which is formed by lens. Okay. Now there could be three situations, okay, for which we can have the final image formed at the source itself. Okay. What are those three situations? I'll discuss one by one. One among them is shown here itself. Let me change the color so that I can explain you. Okay. So let us say this is case 1. So in case 1, let us say I2 is formed at focus of M1. If that is the situation, this I2 is going to act as an object for the mirror M1. These rays will now get reflected by the M1. If this is at the focus of this mirror M1, then the rays after reflection will be parallel, okay, parallel to the principal axis, and these parallel rays will be refracted by the lens, okay, and then after refraction they will actually form image at the focus of the lens itself. And see, this is the source is actually sitting at the focus of the lens. So this is how the final image can form it here, and rest of the thing trace again the same thing. Okay. Alright, so this is one situation. So for this situation, if this is 10 centimeter and this is 8t by 7 centimeter. Okay, so what will be the distance between this? If I say this is D1 for the situation 1, so D1 will be, see, this 10 centimeter plus 8t by 7. Okay, so this much, that means you will have 150 centimeter, 150 by 7 centimeter. So what is the value? So n by 7, I have to find out the value of n. So we are getting case 1, n is equal to 150 centimeter. So this is one case. See, second case, rest of the things will be the same. Like, see, this will be 60 centimeter, the image formed by mirror M2. So this will be the virtual image. This is image 1. Look, the ray diagram is something like this, and this will act as, this I1 will act as object for the lens, and the final image will be formed somewhere 80 by 7. But this position, how is this position for the M1? Okay, so where the I2 is forming with respect to the mirror 1. If I say case 2, I2 is formed at pole of M1. Then see how we are going to get the final image to be formed here. This, so this is now 80 by 7, the whole distance, because the I2 is formed here. Okay. Now these rays will be actually reflected by M1. See, they will be interchanging. Okay. So if I just give some notation, so this ray will be this one. Okay. Look, this one. After reflection. Okay. Now this ray, if I give this way, this ray after reflection, they are becoming this one. This ray actually getting interchanged, and the path will be retraced. You look here, okay, path will be retraced and final image will be formed at this. So this is another situation. In that case, the value, so distance D2, say D2 will be 80 by 7, right? So this will be 80 by 7. Second situation, n will be 80 centimeter. Now I will have another situation, case 3. See, when I2 is formed at the curvature, center of curvature, at the center of curvature of M1. So in that case, this is your center of curvature. Okay, let us say this is C1. So this distance is 80 by 7. 80 by 7. So rest of the things are all same actually. Okay, the image formed by this M2 will be here at 60 centimeter. That is actually not going to change. Okay, this is identical, and the image formed by this L is also at 80 by 7 centimeter away from the lens. So that position is, that image position I2 is center of curvature for the mirror 1. In that case, the rays will be retraced. Okay, after reflection the ray will be actually coming back in this way, and see the path will be retraced by the rays. Okay, so they will be coming back like this. Okay, so that's how you get the final image. Again, where? Again at this source itself. Okay, so in this case, what is the distance? Let us say this distance is D3. So D3 is, radius of curvature is 20 centimeter plus 80 by 7. So this will be actually 140 plus 80 divided by 7. So this is 220 by 7 centimeter. So I have to find out the n is then 22. So I could have 3 situations and I could have 3 values of n. So n will be 220 centimeter. So this is the answer for this question. Thank you.
Why waste time in commute and spend a lot of money for iit-jee coaching? Parents, do you want your kids to achieve top scores in NEET? India's leading online NEET coaching, 100% success. iit-jee. TeenEinstein.com. At TeenEinstein, we focus on NEET coaching from Class 6 to Class 12. We think you'll like it. Our teachers are mostly PhDs in physics, maths, chemistry, botany and zoology, with lots of years of teaching experience for Class 6 to Class 12. Thousands of videos, quiz, MCQs. We provide a daily worksheet of 30 questions on each topic: math, physics, chemistry and biology, for rigorous practice, concept understanding, evaluation, quizzes and thousands of videos. Limited offer, 40,000 per year. Book your class. TeenEinstein.com. Contact 99402 49720.